Welcome back. For this problem, we have if x is equal to 2 sine theta, then the integral from 0 to 2 of x squared over the square root of 4 minus x squared dx is equal to what? So the first thing that we want to do is take this x equals 2 sine theta and then substitute it in and see what happens. So let's go ahead and do that. So we have the integral of 2 sine theta quantity squared, and then we're going to put that over the square root of 4 minus 2 sine theta quantity squared. And the dx, I don't want to write dx there because now that we're moving to the theta world, we should take dx d theta. So dx d theta is equal to 2 cosine theta d theta. And because they give us x equals 2 sine theta, we can just go ahead and substitute this in. So we can just say this is equal to 2 cosine theta d theta. So let's go ahead and clean this up a little bit. Let's take this 2 and move it on the outside. So we have 2 times the integral of 4 sine squared theta. And then let me use straight lines here to make it less messy. And then we'll do square root of 4 minus 4 sine squared theta. And then now this is, we don't want to forget that we move the 2 to the outside, but we don't want to forget the cosine theta d theta. And then we can clean up even further. We can bring this 4 out here, and then so let's make that 8 times the integral of sine squared theta cosine theta d theta. And this is going to be over the square root. And what we'll do is we'll factor out this 4. So the 4 factored out leaves us with 1 minus sine squared theta. And then this is also, again, we already have the d theta up there. So the square root of 4, that's just 2. So we can bring that part out. And so then 8 divided by 2 is just 4. And so we have the integral of sine squared theta cosine theta d theta. And this is all over the square root of 1 minus sine squared theta. But again, from the Pythagorean theorem and the Pythagorean identity, that is, we know that that's equal to cosine squared theta. Now the square root of cosine squared theta is just cosine theta, which means this whole denominator will cross off with this. So then we are left with, this is equal to the integral, 4 times the integral of sine squared theta d theta. However, we need to go from the x world 0 to 2 to the theta world. So we want to go ahead and change that. So for x is equal to 0, we use the original equation they gave us, x is equal to 2 sine theta. So we say 0 is equal to 2 sine theta, which means this would cross off. So if we take the inverse sine of this, so the inverse sine of 0, the inverse sine of 0 is equal to theta. So this is really saying for what angle theta do I have a ratio of 0, and that would of course be 0. So theta is equal to 0. And then for x is equal to 2, do the same thing, we just plug it in. 2 is equal to 2 sine theta. These two cross off, and then we're just left with sine of theta is equal to 1. And again, we can take the inverse sine, but we can just say for what angle theta do we have 1? Well, looking at our unit circle, you know, x is equal to cosine theta, y is equal to sine of theta. So right there we have a y value equal to 1, and then that is equal to sine of theta. So that would be happening at pi over 2, or 90 degrees. So in this case, theta is equal to pi over 2. So our final answer is equal to 4 times the integral from 0 to pi over 2 sine squared theta d theta.